Alrighty guys, welcome back to Team Junkyard Dog. As you can see, there's a big pile of parts sitting here on my desk. And what are these parts for? That's right, we are bringing back an OG form of Rougaroo. So in this video today, we're going to be turning all of these parts into the new Rougaroo for the next event at the Spam Center, August 29th in Stewart, Florida. So without any further delay, let's go ahead, bring the camera in closer and get into this build. So some of you have probably guessed, Rougaroo is going back to more of a, it's still a slight undercutter, but more of a mid-cutter horizontal. I didn't like the extremely low undercutter because I just felt like it was not effective, not enough reach, and I missed the old style Rougaroo. What happened was Carter on Father's Day, when they gave me my card for Father's Day, there was a thumb drive attached to it, and Carter had CAD me an entire new Rougaroo, and that's the one that we're going to be building today. I'm running 6mm G10 plates for the top and the bottom to support this big weapon. This is currently a 12.7 ounce blade. This blade is too heavy. I'm thinking about modifying this by removing the front leading edge here and making it more of a stabbing horizontal. And I did order some thinner blades because these are just too heavy. We're going to be running a TPU body, as most people do these days. I'm also going to be doing some experiments with some foaming TPU as well. To bring up our sponsor of today's video is PCBWay. PCBWay was kind enough to offer me a discount on some CNC machined parts. Therefore, I had these hubs made. If you are looking for some high quality parts, definitely check out PCBWay. Of course, they can help you customize your own PCBs. They can do 3D printing. They can print all types of engineering materials. And of course, they can do 5-axis CNC work. And you guys can see how amazing. Let me show you up close here. You can see how beautiful these 70-75 aluminum pulleys are. They came out very well nice. They're very well machined. Now I did end up altering my main pulley over here, and it was just because I rushed the design and I actually sent them an incorrect file. So I did use my lathe to widen the belt ride where the belt rides here. And then I just, because I didn't have a proper thread in here, we just went onto our lathe and turned down some 8/32 nuts and then pressed them into the holes here. So we have steel threads and an aluminum body, and it's going to be running a 10mm shoulder bolt. So should hold up quite well. But I do want to thank PCBWay for sponsoring this video and having these parts made for us. Now, of course, I'm also going to be running some Repeat Pro drives. The Repeat Pros are our favorites currently that we have been running. These are the 6S 1900 kV because I am planning on running this on 5S. The motor we're going to be using for the weapon is going to be a badass 2315. Now this is a 2300 kV. I don't really recommend trying to spin an 8-inch blade with a 2300 kV motor. I'm going to try it just for consistency, I guess you could say, because me and Carter, I try to have us both run the same parts. That way, if he needs a spare or I need a spare, we can easily swap those out. If this does not work out, I am then going to try Repeat Robotics belt drive motor and see if I can incorporate that into this design. So there's nothing left to do but to go over the build and to start building this and showing you guys what we're going to be doing here. All right, so these are the top and bottom plates that we're going to be using. We just went ahead and just made them all the same. That way, if you needed a spare, it didn't matter. Top and bottom's all the same. You can flip one to the bottom, one to the top. It doesn't really matter. These are 6mm thick G10. We did cut these out ourselves on our Snapmaker Artisan. Thank you, Snapmaker, for sending us that Artisan. It gives us the ability to design and make our own parts on the fly with no waiting whatsoever, which is very nice. But we're going to take our first plate and we're going to take our body. We do have, I think they're 30mm standoffs pressed into the TPU. And we're going to go ahead and attach this. It does recess into the chassis, so it gives it a nice sleek look. Those of you who know us personally, you know Carter is the designer and I am more of the builder. But Carter does build and design his own robots. He started when he was 8 years old, and he does now at this point everything on his own. In case you're wondering, this is the actual bottom plate. And I know that because I put a cutout here for the motor wires to come through. Alright, with the bottom plate attached, it's now time to put in our weapon motor, the Badass 2315. This is a 2300 kV. I'm fairly certain I'm going to roast this one in competition. Now I do have to remove this shaft because we don't want that getting hit. Let's go ahead and do that next. Now when it comes to removing shafts like this, some people like to use a Dremel tool. Me, I just like to do it as quick as possible. Shaft gone. Alright, so with the shaft removed, we will feed our wires back into our chassis. Normally I actually attach this to the plate first, but for some reason I didn't do it that way this time. And now remember why I do it the way I do it. So now we're just going to attach our weapon motor. Do chamfer all your screw holes, guys. It's not just to make it look cool and flush, it's to help protect your screw heads from getting hit and whacked. Most of you would probably be adding Loctite at this point. I will go back through this robot after my testing. I'm not going to Loctite it until I know everything's working. This is the motor I'm going to actually be using. And then once, probably a day or two before the competition, is when I would be going through this robot and Loctiting things like motor screws and set screws. Because until then, when you're doing mock-ups, you're very likely to pull it apart again at some point. And just like that. Now the belt I'm going to be using is a Best Torque. It's a 399-3M belt. The width on the belt is, I don't know, 9 millimeters wide. So a nice wide one. And this is where we will start adding our weapon stack. We are using these 10 millimeter by 50 millimeter shoulder bolts to support the main weapon, and I will slide that in from the bottom. A flat washer, a roller bearing, and then another washer for the bottom stack. And then we will take this, we will line it up just like this, kind of work the belt down a little bit. So now what I have to do before I can actually properly install this is I do have to chamfer the edges on this actual weapon blade. And I hate to waste the drill on it. Well, it's not really wasting the drill, but put the wear and tear on the drill bit because this is not the one that I'm going to be using forever. But for all intents and purposes of demonstrating, I'm going to do it anyway. So I'm just going to leave it right there. What I do like to use whenever I'm putting chamfers on AR500 steel is I use a masonry bit. You want to get a carbide tipped masonry bit because it cuts through AR500 pretty much like butter. Not a whole lot of resistance there. I don't always use oil on the bit, but people get upset when I don't. So for the video, I will. And let's see what we can do here. I'm swapping bits here, just to get a little more shape deeper down inside. I'm sure I'm going to have to go a little bit deeper with these, but I do like to try to get them somewhat flush. So I do need a little bit, the next wider bit, but you can see how it works. And of course these will be Loctited in future as well. Because what's nice about adding our own steel inserts into this blade is if we strip or damage one of these screws, you can punch those out and we keep extra of these made and we can just press in some more to get us a fresh set of threads. That way we never actually wear out the aluminum or threads in the aluminum. Alright, now to install our belt. It's always the shoulder catching everything. There we go. We can see that weapon stack is moving pretty freely, pretty nicely. It does worry me that it is a little bit too close to the top of the can. However, the way the top plate sits right above this, so the belt can't actually raise high enough to come off the motor. It will actually hit the top plate first. So now we're going to get our top plate. We are going to drop on a roller bearing. I'm just going to let it ride on the pulley here, and then we'll put a washer to protect the G10, and then we're going to just press this on. There we go, just like so. And yes, I will be cutting that nub off. Now we'll get our top plate secured on. There you go. Next step, let's get it wired up. All right, so we're going to start with the electronics with the drives. I am currently prototyping, so printing some top and bottom plates for this. I don't know why I countersunk these screw holes when in essence there's going to be a top plate over that. I don't know. And then you notice here I did eventually have to open this hole up because it was pushing down on the top of the Badass 2315. So I'm going to be opening that hole up more. So I will have bottom plates and top plates built differently. So much for that plan. So these are just going to just slide in right here. They are, Carter did actually cat in some recesses into the chassis for them right here. And so these will just slide in like so. And then if I need to, because we're just going to use washers in the TPU, and that's going to act kind of like a suspension. But if they get too flimsy, I do have some backup plates that I can actually put either inside or on the outside to help stiffen that section up. But before we can put these in, we have to safeguard these. So I have a couple of these. These are basically protectors for the motors. The motors go through these, and it protects the motor from any wires or batteries or components pushing up against that motor. And the way that you put these in is you just take these 4 screws out, you pull the top off, you slide it on, slide it back on, and you're good to go. And this was a design given to me from Andy with Palm Beach Bots, so thank you, Andy, for this design. And then once you have these installed, this is what they look like. They have a cutout for the wire, and if anything comes up in contact with this will keep your drive from going out or stopping to spin, and you just simply insert it right into your chassis. Alrighty, and there we go. We have our drives mounted in. They're way more rigid than I actually thought that they were going to be. I may consider putting washers in here if I feel like these are going to pop through, but that's a good solid 3 mil of TPU right there, so I don't think they're going to be going through that, and they are quite rigid, so I'm not really too concerned about that, to be honest. They'll probably get ripped all apart before they get ripped out, because the weight battle on this robot is real, and so I know I'm going to have to reduce these shafts down, and I'm going to actually be running a thinner blade. This is a 1/4 inch blade. I'm going to have to drop down to a 3/8 blade, but on the on this 1/4 inch blade, you can see where I've marked it in silver. I'm actually going to cut this out and make it kind of like a stabby horizontal blade, which I know one hit from a vert and it's going to be toast, but it'll be a fun experiment to see, because it'll basically be like swinging around an 1.5 inch dagger or an 1.25 inch dagger. So it'll be a fun experiment to see how that works out. But now what we're going to do is we're going to pull the wiring harness out of this undercutter version of Rougaroo that runs the dual tangents, because it's easy enough just to disconnect these tangent drives and connect here, plug in to the weapon ESC, and the robot's going to be ready to go. So easy peasy, lemon squeezy. And there we go. Our soldering is done, because I was lucky enough to have pre-made harness in another Rougaroo, which is basically all the same components. So now we just need to do a quick test to check to make sure that our radio is hooked up correctly. Before I do that, I am going to disconnect one of the leads for the weapon, because we don't want this thing just spinning unexpectedly and erratically for sure. So we'll get our radio, we will switch our modes. We'll just grab this little 4S battery here, connect her up. Power on the radio, power on the robot. Okay, That was not the right setting, but we'll just go ahead and bind the receiver to this one. And now I notice that some of you guys are probably thinking, why did you put electrical tape on your drive ESCs? You should shrink tube that. Well, to me, shrink tubing is more of a long-term fix. Combat robots is more of a temporary fix. So I just like to use electrical tape and leave a little tab on here. So if I have to quickly swap something out, I can just grab the tab, whip the tape off, and do my repair. It's a preference. And now we're going to hold down, this is an FS2A. So we hold down the little button and we power up the bot. And we get a flash, fast flashing. And we hold down our bind button on the flash guide, powered up. And they are now bound together. So now we have forward, reverse, right, left. This one is turned down, obviously, from another robot. And the trims are off. We'll worry about all that later. So right now, this one's correct, this one's reversed. So I'm going to go into here and go to my reverses. They are now all correct. I just had to reverse channel 1. Now my there we go. We are now set up with radio. Now I'm going to power the robot off again because I need to verify the direction. So I will be connecting up this motor wire, and then I'm going to insert a screwdriver into here. Feels kind of stiff still. I think I'm about to clear this out some more, but we'll see if it'll spin it or not. I don't know if it will. More clearancing to be done, but I need a different screwdriver in there. Now we'll power this up again. That is reversed. Power it off. Swap a couple of these wires here. Power it back up. And now it's spinning the right way. But as I said, I do have to get this clearancing issue resolved with this motor up here, and that's probably what I'm going to do next. That way I can actually put a bottom plate, a top plate on this, we'll slap some wheels on it, and we can throw it in the test box to see how it's going to spin up. All right. And it's only on 4S.
Alright.
Looks like we can go with a slightly shorter tire.
Yeah, I would say that. I would agree. Is that 0 on the
ESC browned out. So that ESC is not going to work. Down. No final 2 beeps.
Our sound is pretty well.
That was almost half.
It seems like it's. I like how it's like the blade is semi digging into the wall.
Yeah, that 2300 kV is not going to cut it. It is not happy. We're over amping that ESC. About 20%. I'm not gonna blow it. There you go, guys. There's the test. 2300 kV ain't going to cut it for a weapon that size, so we're definitely going to order some 800 kVs And hopefully they'll get here before the competition. I definitely want to get a better wheel than that, but that very easily could be the wheels that I run, so we'll see how that goes. But they are a little too tall. It is kind of raked a little bit. I'd like it to sit a little more level. But with that being said, we'll see how it goes. We will do a follow-up video on how this does in comp. And we appreciate you guys watching, and we'll see you guys on the next video.